Welcome to a new Tea and Table episode. I'm Annie, and this is a cozy little design diary podcast in which I talk about making a board game. To be specific, I'm making a cooperative board game about hacking into a computer network, working title Infiltration. But stepping back a bit, this is already episode 7, and I just realized that I actually haven't told you what my favorite type of tea is. This is pretty outrageous, and we'll fix it now. So my favorite type of tea is Darjeeling black tea. To be precise, Darjeeling first flush, meaning that the tea is from the first harvest of the year in spring, which typically makes the tea less intense and more subtle, or as some people would say, tasteless, but obviously those people are morons. And with that out of the way, I actually have a tiny little announcement for the podcast, some housekeeping if you will. By popular demand from, at least 2 people, you can from now on expect new Tea and Table episodes on a specific day of the week, and that will be on Tuesday evening. So you can listen to new episodes on Wednesday morning, on your commute to work, or depending on your job during work, whatever works. So moving on to the actual meat of the episode, continuing from last time, this week we'll focus on how the AI works, the opposing force that every cooperative game needs to create pressure and a way for players to lose the game. Now, in the last episode, I focused on the card play in my latest iteration, and I'll give a quick recap in a second, but I highly recommend that you listen to that episode first so that this one makes sense. The title of that previous episode was Making My Game More Interactive and Less Bureaucratic, and it was episode number 6. For this episode, also by popular demand of at least 2 people, I uploaded some pictures of mock-ups of the game, and you can find the link in the show notes to this episode. I'll do my best with all of my descriptions, but I'm pretty sure it's going to be much easier to follow me if you stop for a moment now and take a look at the pictures, or even better along the way as you listen to this episode. So here's a quick rundown of the key aspects of the card play as introduced last time, and be sure to check out the first picture in the album in the show notes to see 2 example cards. So at its core, the card play is a deck building mechanic with multi-use cards, meaning you only ever trigger 1 out of 2 possible options on a card when you play it. You can imagine a top and bottom half on each card, and upon playing a card, you may trigger either the top or the bottom option. These options have 4 broad categories. First, commands are the most interesting and flexible category, allowing you, for example, to perform hacks. Second, CPU resources are required to run commands, and players may contribute their CPU to other players' commands. Third, decryption keys are required to decrypt data you extract from the servers in the network, which is the goal of the game. And fourth, movement cards allow you to move around the network. Now, my Tea and Table episode number 3 was titled Game Flow, or How I Stopped Worrying and Got Rid of Rounds. And we'll now dive deeper into how that works, what powers the AI in the game, and how it creates pressure for players to make progress. There are 2 parts to the AI. The first one are anomaly cards that are a part of each player's deck and represent the suspicious network activity a player generates by moving around the network, trying to breach servers and collecting data to win the game. These anomalies have a number on them, ranging from, say, 1 to 5, and representing how easy they are to detect. The second part are surveillance nodes in the network. As a quick reminder, the network in the game is a map in the middle of the table that consists of individual tiles, so-called network domains. At this point, check out the second picture in the album you can find in the show notes, which will show you 2 example domain tiles. On each domain tile, there are multiple interconnected network nodes. You can imagine a bunch of circles representing servers and devices in the network, connected by lines that signify that you can move between 2 connected circles or nodes. Importantly, some of these nodes on each domain tile are surveillance nodes. They represent the entities that guard and watch the network, trying to keep it secure and to detect intruders like you, the player. And these surveillance nodes interact with the anomaly cards in your deck. Whenever you draw an anomaly card from your draw pile at the end of your turn, you immediately resolve and discard that anomaly card. In order to resolve it, you compare the number on it to the number of active surveillance nodes on your current domain tile. For example, if your anomaly card has a 1, that means it only requires one open surveillance node on your current domain tile to detect this anomaly, so it's very easy to detect. On the other hand, if the anomaly card has a 5, for example, the anomaly is much harder to detect since that requires at least 5 open surveillance nodes. Now, if the number of surveillance nodes is high enough to detect the anomaly, that raises the alarm by 1 and you lose the game if you reach a certain alarm level. Crucially, players have some control over how many open surveillance nodes there are on any given domain tile, because this is how you perform hacks in the game. You run commands to hack surveillance nodes within range, meaning you cover them up and therefore reduce the number of active surveillance nodes on the tile. Also, some of the nodes are your target servers, the nodes in the network from which you're aiming to exfiltrate the data that ultimately lets you win the game. And once you've covered up all surveillance nodes adjacent to one of these servers, you've successfully hacked the server and may move to that server node to gain the encrypted data in order to start the decryption process. Some hacks have a higher cost to execute, so to play the card, and are more powerful. For example, they may let you cover up multiple nodes, or they may have a higher range. Finally, I need a way to create constant pressure so that players cannot simply hack all surveillance nodes on their domain tile and then stick around that tile forever to level up and improve their skills. I have some ideas in mind, but I'm still cooking up the details, so I'll cover this in a future episode. So what do these mechanics accomplish and why do I like them? First of all, I think making the cards in players' decks trigger the alerts is a great way to avoid a lot of separate upkeep and extra game structure to operate the AI, which is a major design goal for me and can be tricky to do in a cooperative game. In prior iterations, many of my ideas revolved around cubes you'd have to add to the domain tiles in the network and then potentially even move around to chase after players. My second point is related to this first one. This AI mechanic requires very few extra components, which is another one of my goals. I want to keep the set of required components small and only introduce additional components with intention. Now, the only additional component type I need for my new AI mechanic are the anomaly cards for players' decks, and cards are essentially the most standard game component. Unlike cubes, they don't potentially make the game too bitsy or fiddly either. Third, as I mentioned in previous episodes, I like the idea of giving players some degree of control and agency over when the AI triggers, to allow for some strategizing around that. Finally, there is the hacking mechanic, where you hack into surveillance nodes to cover them up in order to eventually gain a benefit from adjacent server nodes, like encrypted data or new cards for your deck. This mechanic solves an issue I had in the previous iteration, where there were 2 different ways to hack into nodes and cover them up. You would simply move onto surveillance nodes to cover them up, and you'd then have to play hacks when you were on a server node to exfiltrate data. I didn't like that there was no clear distinction between these 2 activities, or at least it wasn't clear why they would work in different ways. So the new mechanic solves that by providing just one specific way to hack nodes, which is to play commands that allow you to cover up the surveillance nodes. After that, any unguarded adjacent servers can be plundered for data and other benefits, which also makes more sense thematically. Now, I still have a couple of game mechanics left that I want to talk about, for example, dice that represent skills like creativity, stealth, and persistence, or the AI mechanic that ensures constant pressure to make progress. I'll cover all of this in some of the next episodes, and as always, thank you very much for listening, and I'll talk to you next time.